Chapter 1 From Ecodesign to Design for the Circular Economy and Sustainability. The integration of environmental considerations into product design with the objective of reducing products' environmental impact along their life cycle, ecodesign, has been developed and implemented in companies since many years. But this is not enough. In order to deal with the sustainable development challenges, companies need to drastically change the way they address product and service design and development. The eco-design concept has evolved to broader design dimensions described as design for sustainability. In contrast to the current practice of eco-design, where in most of the cases only incremental environmental improvements are achieved, design for sustainability aims at radical improvements in the three dimensions of sustainability: the environmental and economic ones, and also the social dimension. But both the eco-design and design for sustainability concepts have been developed within a linear or quasi-linear economic model to which circular economy offers a practical alternative. The right combinations of product and service design strategies supports circular economy by closing resource flows through recycling, slowing resource flows where the utilization period of products is extended or intensified, resulting in a slowdown of the flow of resources, and narrowing flows where fewer resources are needed. The Catch-E project proposes to adopt an integrative approach to the concept and practice of design for the circular economy. It is a product service design and development that replaces conventional end-of-life concept by closing, slowing and narrowing the resource flows in production, distribution and consumption processes. It is enabled by innovation and novel business models and aims to accomplish sustainable development through supporting ecosystem functioning and human well-being, and through responsible production and consumption. Product design approaches to slow loops. The key word is durability, and one example is the Fairphone, which has been designed for longevity, easy repair, and modular upgrades. Product design approaches to close loops promote the recycling of materials, the use of materials that can be food for the natural systems, and to make it easy to disassemble and reassemble products. One example is this packaging by Ecovative, made of mycelium mushroom roots, which are grown in byproducts from agriculture and is compostable at the end of life. Product design approaches that narrow resource loops aim at resource conservation. One example is the solid bar shampoo that requires less resources for packaging and transportation. Design for the circular economy, or circular design, takes a new angle when dealing with environmental considerations in design. It is inspired by natural systems, where materials flow in cycles and there is no waste. Aims at eco-effectiveness. This means the transformation of products and their associated material flows so that they form a supportive relationship with ecological systems and future economic growth. The aim of circular design goes beyond reducing the negative impact. It's about having a positive impact. Walter Stael formulated the Inertia Principle, which is about keeping product integrity and restoring the product embodied values with as little destruction as possible. This should guide the work of design for the circular economy. So, do not repair what is not broken. Do not remanufacture something that can be repaired. Do not recycle a product that can be remanufactured. Replace or treat only the smallest possible part in order to maintain the existing economic value of the technical system. Circular design is also related to the transition from selling products to providing services that have the potential to significantly reduce the intensity of materials per unit of service provided. This is one way to dematerialize the economic system. And finally, another challenge to circular design is systems thinking. This means understanding the complex and interconnected nature of any system of which a product is part, the ways the natural system are impacted and the stakeholders involved, and understanding how decisions regarding such product interact with the wider system. When talking about replacing the selling of products by the provision of services, one needs to address the concept of product-service systems. This designation is due to the fact that there are neither pure products nor pure services, but a combination of both, as the figure shows. In the traditional product-oriented business model, the company revenues depend on the number of units sold, and the pressure to continuously grow in sales is unsustainable. In a service-oriented business model, companies sell performance and own the products. The less products they need, or the longer the products last, the better for the business. Product service systems have a high potential for circularity and sustainability. And a possible categorization that is suited to this debate is the following: product-oriented services, use-oriented services, and result-oriented services. Similarly to what we have done with products, we shall now relate services with slowing, closing, and narrowing resource loops. The three categories of product service systems that we have just presented in the previous slide all contribute to slowing loops. Category A, product-oriented services, include maintenance, repairing, and reuse services that extend the lifetime of products. But products are still owned by the client or consumer. Category B, use-oriented services, may be sharing, leasing, and renting, and they provide the capability to satisfy user expectations without them needing to own physical products. And finally, in Category C, the client or consumer is only interested in the result and not in the product or technology behind it. In Chapter 3 of this module and in the Business Models module, you will learn more about these types of product service systems. Services to close loops concern the collection and sourcing of wasted materials and products so that they can be reused, remanufactured, or recycled. Services to narrow loops deliver a function with reduced requirement for materials. Digitalization is a very strong enabler for reducing material resources use. Now take a break and think of products and services you know which illustrate design approaches that slow, close, and narrow resource loops. For further information and complete references, please consult the full text of the module.